In this video, we'll continue our series on integration by parts with another pair of basic examples. And this time we have the integral of x squared of ln of x dx. Now, according to our chart over on the right, Lippitt, logarithmic comes first in this case, and so we're going to let u be the logarithmic function ln of x. And we're going to let dv be the remainder, which would be x squared dx. Again, the reason for this is that the derivative of ln of x, which is just 1 over x, turns out to be a simpler form than ln of x, and x squared dx is easily integrated. It is true that the derivative of x squared would be a simpler form than, which is x, would be a simpler form than x squared, but ln of x, we may not have learned the integral of that yet, but it is more complicated than ln of x itself, and so that would not be a good choice for dv. But you don't need to think about all that. Just use Lippitt and you'll get the right choice each time. So we're going to take the differential of u, which is 1 over x dx. We're going to find v by integrating dv, and that's going to give us x to the third over 3, or 1/3 x to the third. We rehearse our formula. The integral of u dv, which would be the integral of ln of x times x squared dx, is uv minus the integral of v du. So we're ready to put that all together, and we have integral x squared ln of x dx is equal to uv, which is now ln of x times 1/3 x cubed, or 1/3 x cubed ln of x, minus the integral of v, which is 1/3 x cubed, du, which is 1 over x dx. And that looks a little complicated, but actually it simplifies pretty well. The x cubed over x is going to give us x squared, and we'll bring out the 1/3 for a final form of 1/3 x cubed ln of x minus 1/3 times the integral of x squared dx. And we're ready to integrate that final integral now. And so we get 1/3 x cubed ln of x minus 1/3 x to the third over 3, or another 1/3 x cubed plus c, and putting that all together we get 1/3 x cubed ln of x minus 1/9 x cubed plus c. So I'll give you one to try. How about you just change x squared to x cubed ln of x? We'll give you the answer in a second. You can pause the video, and if you need, I'll work out the full solution. Okay, your answer for this one should be 1/4 x to the fourth ln of x minus 1/16 x to the fourth plus c. And if you need, I'll work that out. Otherwise, you can continue on to the next video. So the important thing in setting this up is we need to choose the proper function for u, and according to Lippitt, the natural log should come first. So u is ln of x, and dv is the remainder x cubed dx. We're going to differentiate u, and we will get 1 over x dx, and we'll integrate dv, and we get 1/4 x to the fourth. Remember the formula, integral u dv is equal to uv minus integral v du. Now, putting it all together, we know that integral x cubed ln of x dx is equal to uv, which is 1/4 x to the fourth ln of x, minus the integral of v du, which is 1/4 x to the fourth, and du is 1 over x dx. We can simplify that. We get 1/4 x to the fourth ln of x minus 1/4 integral of x to the third dx. And finally, 1/4 x to the fourth ln of x minus 1/4, and the integral of x to the third dx is x to the fourth over 4, or 1/4 x to the fourth plus c. And the final simplification, we get 1/4 x to the fourth ln of x minus 1/16 x to the fourth plus c. And that does it for this example.